we were discussing about the RPie, the power of the RPie to use or implement a compute-intensive projects. I've demonstrated that with an example, with the capabilities. I've shown the generations, how the computing power, the latest cores of ARM has been used, and also the main memory capacity has increased up to 8 GB. Since you have a lot of computation capability and also the microcontroller capability, like the pins, you can able to use them. It's always better to use RPie wherever you can able to afford 2,000 to 4,000 rupees. Today we are going to build a project using RPie. In that project, I'll be using any of the RPie versions you can able to use. It does not matter. RPie 0 to RPie 1, any of the generations you can able to use it. So I'll be using one sensor, which is useful to monitor the weather. I will write a program in the RPie using the Python code to read the data from the sensor and then upload this data into the cloud. And later we can have certain visualizations in the cloud to sitting there in a remote place. You can able to monitor the weather at a particular place. So let's start with what all the requirements for us to do that one. Now, so we will go with the define the sensor first, which sensor I have to use it, what are the parameters of that sensor, and then I'll make a connection to the RPie. Then we'll write a code and I'll post to things being channel. I'm going to do it. Now, so whenever you are going to use a sensor, always remember that limitation of RPie, you have to remember it. So what is the limitation of an RPie? As I said, RPie do not have analog signals. That is, analog inputs are not available. So I cannot use a sensor like an LM35 to work on that sensor. So since I cannot able to use an LM35 because analog input is not available, I should look for a sensor which throws me the data in the digital format so that I can able to collect the data from a RPie. So one of the popular sensor which is used in the industry for doing a lot of microcontroller based applications is the DHT11 or DHT22 sensors. Very extensively used in the industry, these sensors. These sensors comes in two forms. Either you can purchase only the sensor, use the sensor and put it in your board, that is your product, whatever you're going to build it, or purchase a sensor module or a sensor board like this. So the board already plays the sensor on that, and one or two components like a resistor capacitor soldered on that, and they give the required 3 pins output of it. So either I can purchase the sensor with the 4 pins, do the necessary circuit in my circuit, or I can purchase a board which houses the sensor, do the necessary connections, and the components has been placed and ready to use in your microcontroller or RPie based board. So in this project, I'm going to use the sensor module or sensor board, which is already housed what is required for that. Now, what is the name of this sensor? Is a DHT11. Is it analog or digital sensor? It's a digital sensor. Why it's called a digital sensor? Because the measurement of temperature and humidity is done inside the sensor, and then it is communicated to the external world using the pins. What do you have it? What are the pins you have in this sensor? This sensor provides 3 pins. One is called as a VCC, other is called as a ground. What is the range of voltage? 3.5 to 5.5 voltage. Since RPie provides a 5 volts, I can connect the 1 pin, the VCC, to the 5 volts and the ground pin to the ground pin of the RPie. Now there's one pin called data. It outputs both the temperature and humidity through the serial data. In a sense, that is one pin, the middle pin, it's called as a data pin, which throws me the data in the digital format, both the humidity and the temperature. So you can ask the question, sir, there is only one pin is there. How can RPie and the DHT11 can communicate? Yes, it is a single pin or single line bus. In a sense, I can use the same line to communicate from RPie to DHT11, but also I can also use the same pin to communicate from DHT11 to the RPie. Only thing is I should follow the protocol specified in the DHT11 datasheet. Now, let's go to the details of the DHT11. DHT11 is a basic, it's a basic ultra low cost digital temperature sensor. Around 100 rupees is the cost of this sensor. So it is used to measure both the digital temperature and low cost. It uses capacitive humidity sensor. What does it mean that? That means that digital level calculates the relative humidity by measuring the electrical resistance between the two electrodes which has been placed inside. The humidity sensing component of the digital level is a moisture holding substrate with the electrodes applied to the surface. That means that inside there is what is called as inside there's a capacitive humidity sensor with the two electrodes and the substrate is present inside. So the substrate is capable of identifying the surrounding humidity and able to give me the data and the humidity in the digital format. That is how it measures. Now, so it has got a thermistor inside. It has got a thermistor inside, NTC thermistor. So the thermistor is exposed to the surface. Of course, if you look at the plastic package inside, you can see the thermistor. The thermistor is used to measure the surrounding air temperature. That is temperature what is there in the surrounding air. So it has got a thermistor and a capacitive humidity sensor built into this package. Now, so when you are able to use this sensor, what are the specifications of this one and what are the applications of this sensor? The applications of you can use to build an equipment which can measure temperature and humidity. You can able to build local weather station. You can able to local or cloud-based weather station. You can able to build. You can use for automatic climate control like a greenhouses where you have to monitor and also control both the temperature and humidity for the plants which are grown under the greenhouse. So for that, people use this sensor. It's very much essential and it is sufficient to implement a greenhouse project. And environment monitoring. For example, you want to monitor the environment parameters at different places in a city and aggregate them in a cloud, and you should be able to project the different places, Google places and their environment conditions. You can able to use them. These are some of the applications. Now, what are the specifications of that? So, as I said, operating voltage is 3.0 to 5.5 volts. The current it takes, as you can see that when you are not using that, what is the current? 60 microampere standby. That means that it consumes very, very less current when you're not using the sensor. That is, protocol is not exchanging between the DHT11 and your RPie. So when you're measuring, it takes only 0.3 milliamperes. What is the format of the data? It's serial data, serial digital data. So temperature range you can measure is 0 degree to 50 degrees centigrade. So unlike LM35, which is capable of measuring for a larger range, this has a limitation of measuring only 0 degree to 50 degrees centigrade. For normal applications like a greenhouses, weather monitor, it's good enough. If at all, if you require a more range, then go for the same thing, DHT22. It gives a little larger range. What is the humidity range? 20% to 90%. Again, if you want a bigger range, that is a larger range, always go for a DHT22. What is the resolution? Its resolution is less compared to your LM35. So both are 16-bit in the sense, I will explain that. How do you receive, what is the 16-bit means? Accuracy is plus or minus 2 degrees centigrade, plus or minus 5% is an accuracy you get using the specification of this one. So now we have understood how it has been built inside. That is a capacitor and a thermistor is used. We have understood the number of pins, what is provided by that. We also understood the specification of this sensor. Now let's go to interface this sensor to the RPie, and then we will understand what is the protocol required for that. Now, so whenever I want to connect this to an RPie, so what do I require? So I require an environment. What is I am going to build this one? That is in the sense. So let's say this is an application I'm going to build now today. So what is an application? I have an RPie. So RPie is acting what is an IoT agent. It's acting as an IoT node here in this case. Of course, there are other two sensors are there. I'm not using that sensors today. I'm using body temperature and a humidity sensor. That is DHT11 is connected to the RPie. Then I write a program to read this data and send this data to a ThinkSpeak cloud. So I can perform the analytics from the MATLAB or a code there only and able to watch it. Or I can write an application in a computer using a Java or Python. I can pull the data from a ThinkSpeak using a READ APIs. I can display it. Or I can write a mobile application. One aspect is either you can access directly from RPie or you can use a mobile application to pull the data from a ThinkSpeak and able to display it also. If you're doing alert messages, so you don't require ThinkSpeak, you can directly send also. So this is the architecture of the project what I'm going to discuss now. Now, There are so many pins are there, as I told yesterday. So the pins, what is available here, there's a lot of pins are available on the here. I can use any of the pins for building this project work. So as I said, the pins of two types are there. Either I can go for the pin numbering here, which is called as a system on chip package, that is a BCM package, that is a microcontroller based numbering, or I can go based on numbers printed on this one, the board numbering equivalent. Today I'm using the microcontroller based numbering, that is system on chip numbering. I'll be using GPIO 4, that is pin number 7. So 1, 2, 3, 1, 3, 5, 7. So I'll be using the pin number 7 to connect to the DHT11 data input. The other two inputs, one is connected to the VCC, which is available 5 volts, I'll connect here, other to the ground. So these are the connections I'm making. So one for the 7, that is a GPIO 4, I'll be connecting it, other for this one. So what is my number? Number is 4. I should remember the number as the 4. Now, once I identify the number, that is 4 is connected here, I have made the connections. My connection for the DHT11 sensor is ready now. So whenever the DHT11 sensor is ready, then how do you start programming? There are two ways are there to program your data. So one is either understand the datasheet of DHT11, you write a program on your own without using any of the libraries. You don't require a library at all. So this is always advantage to learn the lower level of programming. For example, you have a microcontroller, you don't have a library for the DHT11. How do you do? We have to understand the working methodology of the sensor, and we should establish the protocol to read the data and able to implement a library by our own. In this case, that we'll be learning in unit 4 and 5. If there's no libraries there, how to establish using a timers and other things. So today I'll be using a library. But before using the library, what is the protocol I'll explain? I said there is only one line is there. It's called as a data line, which connects the DHT11 and your RPie. That's a pin number, the 4, GPIO 4. That is I have connected it. Now this only one pin which is available, that is a one data line is available, which you use to communicate between the host. Host is what? That is the master is what? RPie. So who is a slave? The DHT11 is a slave. That is a device. How do we use it? First the master, the RPie will generate one pulse. That is always the line is high because the pull-up resistor is used in the sensor module. So whenever always the line is high, whenever we want to get the information from DHT11, what we do, I'll pull the line low and make it high for a particular time. These times are fixed. Whenever I do that one, DHT11 understands that DHT11 is always in the reading mode. It understands that, oh, some master requires the data, that is temperature in this one. Immediately what it does that, it gives a response signal and then sends the data, complete digital data, it sends it, and then it makes it again the bus, release the bus. So this is the protocol what is used between the DHT11 and any master. So first the master should initiate the transfer, then the slave will give the response, and then the data in the digital format will be sent and then release the bus. Since it's already predefined, in the sense when the sensor is manufactured, they've already defined what is the duration of the 1 bit. Is all times are fixed. Only thing when you write a program, follow the same timings, then the data you gather from the DHT11 will be perfect. You have to synchronize the data properly. So data line is used to send the data also, to achieve the synchronization also. Now, how many bits of data it sent? 40 bits of data it sent. That means that in the 40 bits of data, it embeds both the humidity, both the temperature, and also the parity, and then sends back the data to a RPie. We will understand how that 40-bit data is there. Now, the format like this. For example, if I communicate, if I initiate the request from the master to send the data to a DHT11, I receive the 40 data. What is a 40-bit data? The first 16 bits are related to the moisture. The second 16 bits are related to the temperature. So totally how many? So 16 into 2, 32 bits. Remaining 8 bits is a parity. So these 8 bits will check the correctness of these 32 bits. How do you get the parity? Add the first 8 bits to the second 8 bits. Again, add the second 8 bits to the third 8 bits and third to the fourth. Whatever you get, that will be this bit. That is a parity bit. So once the master receives these 32 bits, it verifies by calculating the parity of this 32 bits with the parity bit what has been communicated by the sensor. If both are correct, that means that you receive the data properly. The synchronization has been achieved properly. Now, what is the meaning of the first 16 bits? The first 16 bits is used to communicate humidity. How does the humidity will be there? 8 bit is used for the integer data. 8 bit is used for a decimal data. Generally, decimal data will be 0. So that means that, so the 16-bit resolution I said, that is 8 bit for integer data, 8 bit for decimal data. Similarly, for the temperature, 8-bit is the integer data for a temperature, and again 8-bit is a decimal temperature data. So generally, for example, I have taken one example here. If this is my data set, if this is my 40-bit data, look at that. Decimal portion is always generally 0, and here also decimal portion is 0. Now, what is a parity? I'll add all this number. Parity is what? 0100 1101. It is similar to whatever you received. That means the data is correct. Now, how do you extract the data? First, take the humidity. Take 0011010. That is equivalent to 35. 35, it's in binary format or hexadecimal. Convert into decimal. So 16 into 3 plus 5. That is, this is 60. How do you convert? 5 into 16 to the power of 0 plus 3 into 16 to the power of 1. That is converted into decimal. How much you get? 53. So the 53 is directly, it's calibrated already and pre-calculated. You just read that from your host machine, that is RPie, and just print on the LCD or the Cinemata, throw to the cloud, saying that 53% is a humidity. Similarly, so I will take the temperature. Anyway, decimal portion is 0. So it's nothing but what? 18 in hexadecimal, that is in binary. Convert 8 into 16 to the power of 0 plus 1 into 16 to the power of 1. You will get a 24 degrees centigrade. So 24 degrees centigrade is the temperature. So it's already pre-calibrated, calculated. You have to just read it and get it. Am I audible? Hello?
Yes, sir.
Okay. So now this is the format of how DHT11 sensor is going to work. So now one thing is I have to write a program to do this job, that is receive this data as per the time format and then do it, or go for a libraries which are available in the market. If you purchase, there's a lot of, for example, RPie, Adafruit libraries available. So you can use those libraries to perform directly this data. So I'll be using a library which is already available for doing this one. So it's not required you to write a program, but of course, when there is a library is not available, you should understand that using a datasheet, I can able to always develop the libraries on my own. That is the purpose of learning the microcontrollers at the lower end, because many times your job is what? To develop the libraries. How to develop the libraries? You should read the datasheet, you should know the timing, you should do the low-level timing implementation. That we will see that in the 4 and 5, we will address a certain library development. Now, so now going back to my program. Now I have understood the connections. I have understood the protocol of DHT11. Now I have to write a program in the RPie and send the data to this one. So now what I have done is, so I'll go to the program. So I'll go to the program now. This is the program. So import the GPIO library so that you can access the GPIO pins in RPie. So then import Adafruit DHT. See, this is the library I have imported from Adafruit. So once you have this library is available with you, then the protocol is taken care by that library. You need not worry about how it is implemented. You can just read the data. So I've used BCM. See that in the earlier program, in the last class, I've used board packages. Now today I'm using BCM, that is system on chip numbering. I'm using it. So which is the number I've used? The 4 is the number I've used to read the data set. Now first create an object of an Adafruit DHT11. So Adafruit DHT supports both DHT11 also, DHT22 also. If you require more accuracy, go for DHT22. So 22 provides a more range and also more accuracy for both the moisture and the temperature. So get the sensor object, then read. So Adafruit library provides read. So it's keep trying yes or no until it gets the data. So when it's ready, so it's a blocking call. So what is this? This is a number, pin number which I've used. So I said I'm using a BCM numbering. That is why pin number 4 is used, GPIO 4. So pin number 4, GPIO 4 has been used. Through that, I'm able to reading the DHT data. So once you call this function from the library, it's already humidity and temperature will be filled with the temperature humidity. It's ready. Just one statement is good enough to get the humidity and temperature. Once you have print on the serial monitor of your Python terminal, see that humidity and temperature is matching with what is there in your surroundings. Then once you print that humidity and the temperature on the screen monitor, then it's time for you to post this data to a ThinkSpeak cloud. So as already you're done, a few of the batch students have done it. So there are different ways there to do it. So one method of communication between your RPie and to the ThinkSpeak cloud is an HTTP. See HTTP connection. So I'm just filling the parameters in the header. I'm filling the temperature and the humidity values. My ThinkSpeak key, right? API key is being filled here, and the website and the port number is a web address and the port is indicated here. And then I post the data to a ThinkSpeak. So once I post this data, I can get the response. I can just read the response and I can print also. So this is the simple program. So read from a sensor. So using its library, then use the IP address and the port number to post the data to a ThinkSpeak cloud. Now, so once you conduct this experiment, you can see on the serial monitor in the Python, you can see humidity and the temperature. You can get the readings like this. But also you can observe on the ThinkSpeak, you get a health monitoring signal like this. You can able to get it. So this is how you can able to implement a weather monitoring station using RPie and the DHT level sensor.